In the acid-base titration lab, what you're going to do is you're going to determine the concentration of an unknown hydrochloric acid solution using a known concentration of sodium hydroxide. So we're going to take hydrochloric acid, and we don't know the concentration of our hydrochloric acid. But we do know the concentration of our sodium hydroxide. And the sodium hydroxide that you're going to use for this experiment is 1 molar. So what you're going to do is you're going to set up a burette and a Erlenmeyer flask. You're going to get yourself about 25 milliliters of the unknown hydrochloric acid and about 60 milliliters of the sodium hydroxide. Now, don't try to take your graduate cylinders up to the bench and measure everything out in that. Take some beakers up there, get yourself approximately 25 milliliters of hydrochloric acid and approximately 60 milliliters of sodium hydroxide. It doesn't need to be exact, just get around that volume. Take those back to your bench, and then you can measure out the precise volumes in a graduate cylinder at your bench. Okay, don't be taking up time at the station at the front when other people are trying to get solutions, trying to get your exact concentrations. So what you're going to do is you are going to take your hydrochloric acid, and we're going to measure out, we're going to titrate with the sodium hydroxide, and we're going to see how much sodium hydroxide it takes to neutralize our solution. So if you look at most pieces of glassware, like a graduated cylinder, we know that the graduated cylinder has a 0 at the bottom and it goes up 10, 20, and so on. Or it may go up by 1s if you're looking at the smaller 10 milliliter graduate cylinder. Burette actually goes the opposite direction. A burette has 0 at the top and then it goes down. So you have 0, and then you have 1, 2, 3, and so on. So ours in the lab are measured out every 1 milliliter. And then we have markings for the half milliliter and then per tenths. So let's take a look on the next slide here, and let's zoom in on a section of our burette. So let's say you've done your titration, and we're going to zoom in on the 22 to 24 milliliters. So let's put our markings in here. And here's our half milliliter mark. So let's say you've done your titration, and your volume of sodium hydroxide is about right in there. Now, what some students will do, some students will make the mistake of trying to count up like they would with a graduated cylinder or a beaker. So they'll start at 24, and then this would be 24.5, 24.6, 24.7, and they'll try to tell me that the volume is 24.7 milliliters. But remember, we started with 0 at the top. So your 0 is way up at the top here where we can't see. So we actually record our volume going down on a burette. So remember, we drained it from the top. So this is 23 milliliters, and then we get to 23.1, 23.2, and we're not quite at the 23.3. So remember, when we record volumes, we record all of the places that we can see. So we're at 23.2. And then we estimate one place beyond that. So this is almost on the 23.3, but not quite. It's not quite lining up there, so I'm going to say that this is 23.29 milliliters. So remember, we go down from the top, and you don't subtract this from 50. That's another mistake that students will make sometimes. We don't subtract this from 50 because we started at 0, and this is our end volume. The 50 is not at the top, it's at the bottom of the puree in this case. So let's look at one more example here. Let's say that you do your titration, and you're right about in there. So I have 22, 22.1, 22.2. I'm not quite at the 22.3. But I'm pretty close, but not quite as close as last time. So I'm going to estimate about 22.28 milliliters. So remember, record all the places that you can see. And then estimate one place beyond that. So when I look at your volumes for your concentration, for your initial and final Bure volumes, I should see 2 decimal places. And that will be something that I'm looking at when I grade your results and calculations section from your lab notebook. So you're going to titrate this until your solution in your beaker is a light pink color. So you're going to put phenolphthalein in your Erlenmeyer flask with your hydrochloric acid, and you're going to add sodium hydroxide. Now when you see this, you're first going to have a flash of light pink. And then when you swirl your flask, that flash of light pink color is going to go away. So you're going to keep titrating until that light pink color persists, but you want it to be a light pink. Okay, that part is very important. And it can be difficult sometimes because there's a very fine line. Even 1 or 2 drops can take you from light pink to too dark. If you're unsure, check with me and make sure that you're the light pink and not too dark. Okay, if it gets too dark, you've gone past the end point, and then you'll have to redo your titration, which happens. And there's plenty of time in the lab if you need to redo a titration. So you're going to do your titration until you get to that light pink color. And you're going to do at least 2 titrations. And your volumes for your 2 titrations need to agree within plus or minus 0.50 milliliters of each other. Okay, if there's more than a difference of 0.50 milliliters, then you need to redo the trials. And don't erase your results, okay, because you don't know which one is not correct. So, if you have to do a third trial, just use the space to the side of the table on your report sheet and record your third trial. If you need to do a 4th trial, go ahead. But you need 2 trials that agree within plus or minus 0.50 milliliters. If they don't agree within that plus or minus 0.50 milliliters, then what you're going to find is your concentrations are very different, which doesn't give you an accurate concentration for your hydrochloric acid, because you should be using the same hydrochloric acid solution from the same bottle for both of your trials. So if it came from the same bottle, they should be the same concentration. So something's not right if you get very different concentrations. So let's take a look at the calculations that you will need to do. So you're going to record your initial Bure volume and your final Bure volume, and you're going to record the concentration of sodium hydroxide. And as I said, the concentration of sodium hydroxide is 1 molar. Okay, and we're reacting hydrochloric acid and sodium hydroxide. And our products are sodium chloride and water. Okay, that's what you're going to get when you react those. And that equation is shown on your lab handout. So once you've recorded your concentration of sodium hydroxide and your initial and final Buret volume, then you're going to calculate the volume of sodium hydroxide that you used. So the way that you do that is you're going to take your final Buret volume minus your initial Buret volume. So final minus initial will give you your volume there. So the next step on your table asks you for the moles of sodium hydroxide reacted. So to get the moles of sodium hydroxide reacted, what we're going to do is we're going to take our volume of sodium hydroxide that reacted, and you will have to fill in whatever volume of sodium hydroxide you used here. And we know from our solution stoichiometry that molarity means moles per liter. So this is 1 mole of sodium hydroxide per 1 liter of sodium hydroxide. So we need to convert our milliliters to liters, and there are 1,000 milliliters in a liter. So I'm going to put my 1,000 milliliters of sodium hydroxide on the bottom and 1 liter on the top. And then we said that's 1 mole of sodium hydroxide per 1 liter of sodium hydroxide. So if we put 1 liter on the bottom, that will cancel out the liters, and 1 mole of sodium hydroxide goes on the top. So you're going to plug in your milliliters of sodium hydroxide here, and then you're going to do the calculation and determine how many moles of sodium hydroxide you have. Now the next part of your table asks you for the moles of hydrochloric acid reacted. So if we look at our equation up here, we can see that there's a 1-to-1 ratio. We have 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So let's go to the next slide since we're running out of room there. You're going to take your moles of sodium hydroxide from the last step. And we know from our reaction that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So essentially, your moles of sodium hydroxide is going to equal your moles of hydrochloric acid since there's a 1-to-1 ratio. And then our last step, we need to calculate the hydrochloric acid concentration. And we want that in terms of molarity. We know molarity is moles per liter. So what you're going to do is you're going to take your moles of hydrochloric acid that you calculated in the last step, and you're going to divide by the volume of hydrochloric acid. So we used 10 milliliters of hydrochloric acid, but we know that we need to convert that to liters. So it's 0.10 liters. And once you do that, you will get your concentration of hydrochloric acid. So you're going to plug in your moles from this step. And then we just need to divide that by 0.10 liters. And that will give you your concentration of hydrochloric acid. So make sure that you have read through the lab handout and that you have submitted your purpose and procedure for your lab notebook before you come to lab. So get that done, and I will see you in lab.